Hello, this is team number one, and this is our final project delivery. Our team is integrated by the ones shown on the screen.
We decided to work with the same matrix as a team, but having different reinforcement. In order to create a composite, it's necessary to have a mold, flour, white glue, cornstarch, and water. You just need to choose your reinforcement. Once the composite is ready, it's necessary to use the oven at 160 Celsius for 1 hour.
They are made with our common matrix, and my reinforcement is jute fiber.
Reinforcement I used was coconut fiber.
In my case, I decided to use silk.
I used agave fiber as a reinforcement for my composite.
During this test, we used the maximum power of the flame, measuring the flaming time and the break time. We wanted to measure the fracture by leaving the composite at the fridge for 8 hours and dropping it at an initial height of 1 meter and increasing 1 meter each drop until reaching 4 meters 25 times. Absorption was tested by measuring the weight before putting the composite inside water. Once 3 minutes have passed, the composite will be measured again. By using a 1-ton car and passing the car over the composite, we measure the compression. The composite was dropped from an initial height of 1 meter until reaching 4 meters 25 times. For the vent test, we add 1 kilogram until the vent notices.
We believe our composite can have various applications, mainly as a construction material given its performance during the hardness and bend test, where we were able to see how well it responded when big stresses were applied to the samples. We also performed two height tests. In the room temperature one, we dropped the samples repetitively from an altitude of 4 meters. Mars and Jose Carlos didn't break, where Aldous and mine did. Then we froze another batch of samples for an hour and performed the same test. This time Mars, Jose Carlos, and my samples didn't break after 25 repetitions, though Aldous did break in the fifth fall. For the bend test, we hanged various masses in our samples until they broke, and we were surprised with the results. None broke, and we didn't have more heavy things to hang. On average, the samples endured 18 kilograms with little to no apparent bending and far from fracture, so we estimate they can withstand somewhere between 25 and 30 kilograms, even more than that.
My composite was one of the best at resisting the height and the blend test. It makes sense since jute fiber helps the material improving the cohesion and reducing cracking. In the absorption test, mine was the one that had more weight after it. This could be related to the fact that the fibers allowed a lot of water filtration. At temperature and compression test, the behavior was the expected.
The next test was the car. We ran over our samples 5 times and recorded the results. None broke, and all but mine had different dimensions following the test. We can see how length and width increased, meanwhile thickness decreased. Even though we worked hard and closely with our material, it's far from being useful in the real engineering world. Thousands of tests remain for a new material to be put into use. This taught us how difficult it has to be to design a new material and gives us a better perspective on what lies ahead for us students, and we'll take the challenge.